In the name of Allah, the most gracious, the most merciful, praise be to Allah, and peace and blessings be upon our Prophet Muhammad, his family, and his companions. Now let's begin our course on power system protection. In practical terms, the electrical network is divided into zones. The relay's role is to protect its designated zone as the main protection and serve as backup for others. Each generator, transformer, and line between stations has its own protection zone. If a fault occurs in zone 1, the generator's circuit breaker trips. In zone 2, it will trip the relevant breakers. Any breaker that could supply power to the fault area must trip. In zone 5, if a fault occurs on the bus bar, note the number of circuit breakers involved. This setup is incorrect. It should be, and if a fault occurs in this area, it should trip. The number of circuit breakers that need to trip is every circuit breaker feeding the fault area. Any circuit breaker that could supply power to the fault area must trip. In zone 5, if a fault occurs on this bus bar in the zone, note the circuit breakers inside this zone. 3 circuit breakers, this is completely wrong. It should be 4 circuit breakers. This circuit breaker, if we assume it's outside the zone and 3 circuit breakers trip, while this one remains closed, the fault will be fed from zone 7 through this generator, supplying power to the fault area. This is very dangerous and could lead to a collapse in the bus bar. Therefore, this circuit breaker must be included within the zone boundaries. Any potential to feed the fault area must trip. If a fault occurs on this bus bar, there are 3 circuit breakers, 4 circuit breakers. If this circuit breaker is outside the zone and 3 trip while it remains closed, the fault is fed from zone 7 through the generator. This is dangerous and could collapse the bus bar. Thus, this circuit breaker must be within the zone. Also, this circuit breaker overlaps zone 1 and 2. The overlap eliminates unprotected areas. 4 circuit breakers. If it's outside the zone and 3 breakers trip while this one stays closed, the fault feeds from zone 7 through this generator, powering the fault area. Thus, this breaker must be within the zone. This breaker overlaps zone 1 and 2. The overlap eliminates unprotected areas. Unprotected areas or dead zones must be eliminated in the network. All network areas must be protected. Zone boundaries are set by current transformers, CT positions. The CT is an abbreviation. Now also note with me that this circuit breaker overlaps between zone 1 and zone 2. This area is called the overlap area. The goal of the overlap is to get rid of all areas that cannot be protected. The area that cannot be protected is called in protection science dead zones, and we must get rid of all dead zones in the entire electrical network. Every area in the electrical network must be protected. Now note with me also that the zone boundaries are determined by the location of CT installation. CT is an abbreviation for, from defining CT, the boundaries of the zone are set. I have 2 CTs in transformer 2 and 2 CTs in the transmission line. Each breaker has a CT. What is the relationship of the protection device, the relay, and the circuit breaker? It starts with the relay getting signals from the current and voltage transformers. The relay analyzes these current and voltage values to decide if they are normal or faulty. It then sends a trip signal to the breaker, as shown in the diagram. In this diagram, there is a 3-phase bus bar, red, yellow, blue. From red, yellow, and blue, feeders come through the breaker. The breaker is symbolized in ANSI code as 52. Assume a fault on the blue phase. When a fault occurs, current flows through the bus bar to the fault area. The current passes through the CT. The CT converts the fault current to a smaller value sent to the relay. The relay compares these values to its setting through the circuit breaker, and from the yellow, there's another feeder coming through the circuit breaker, and from the blue, there's another feeder coming through the circuit breaker. The circuit breaker is even symbolized in the ANSI code as 52. Now let's assume that there's a fault on the blue phase. When a fault occurs on this phase, current flows through the bus bar to feed the fault area. The current flows again through the bus bar to feed the fault area, and it will pass through the current transformer, CT. The CT converts the fault current into a smaller value, which is then transmitted through the secondary of the CT to the relay. This relay takes the secondary values coming from the CT and compares them to the setting value stored inside it. In this relay, if the current exceeds the set value, it closes its output contact. The setting is based on short circuit calculations. The bus bar feeds the fault area. The fault current flows to the circuit breaker. The current transformer reduces the high current to a suitable value for the relay path. The relay compares this with the set value. If the current is higher, it closes the output contact, allowing battery current to reach the trip coil of the circuit breaker, which opens it. A fault occurred. The fault current flowed through the bus bar. The current transformer converts the high current into a smaller value for the relay. The relay compares the CT's internal value with its setting. If the current exceeds the setting, the relay closes its output contact. When this contact closes, the battery current reaches the circuit breaker's trip coil, opening it. The relay compares the internal value it receives from the CT with the setting value already present inside the relay. If the current value is higher than the setting value, the relay will close its output contact. When the output contact closes, the battery current reaches the trip coil of the circuit breaker. This trip coil is what opens the circuit breaker. Now, notice that the output contact from the relay when closed allows the DC battery current to flow to activate the trip coil. Now follow me as we analyze this image again. Notice once more that the protection system consists of the CT and the relay and circuit breaker. Now the CT or VT, voltage transformer, relay and circuit breaker, are collectively represented by a square symbol. So if I say this square contains the CT, relay and circuit breaker, now follow me here. Let's assume that the trip coil circuit is inside the circuit breaker. Now the CT or VT, voltage transformer, relay and circuit breaker, are collectively represented by a square symbol. So if I say this square contains the CT, relay and circuit breaker, now follow me here. Let's assume that the trip coil circuit inside the circuit breaker is open due to some fault. What will happen? The trip coil circuit is open. If a voltage occurs and the CT converts the fault current value to the relay and the relay closes the output contact, then the battery current won't flow because the circuit is already open. What happens in this case? In this case, if the triple circuit is inside the circuit breaker, it was open due to some error. What will happen? The trip coil circuit is open. If a voltage occurs and the CT converts the fault current value to the relay and the relay closes the output contact, then the battery current won't flow because the circuit is already open. What happens in this case? In this case, if the trip coil is open or the trip circuit is open, we should have a backup circuit that is exactly similar to it, which we call trip coil 2 or trip circuit 2. This is called trip circuit 1 and the other one is called trip circuit 2. So if trip circuit 1 is cut, we have another similar backup circuit called trip circuit 2. If the trip coil is open the trip coil is open, we place another circuit that is exactly similar to it, which we call trip coil 2 or trip circuit 2. This is called trip circuit 1, and the other one is called trip circuit 2. So if trip circuit 1 is cut, we have another similar backup circuit called trip circuit 2. Trip stolen 2. Now we notice that inside the circuit breaker, I have 3 coils. The first coil is for trip circuit 1, the second coil is for trip circuit 2, and the third coil is for closing. There's also another coil for the charging motor. Now let's assume another scenario. Let's say the circuit breaker has a fault and the bus bar comes to feed the fault area through the CT and the relay gives a trip command. The battery current reaches the trip coil and the trip coil activates, but unfortunately there is a mechanical fault in the circuit breaker and it doesn't open. What do we do in this case? In this case, we move to what's called the breaker filler. The relay issued a trip command and the battery current reached the trip coil and the trip coil activated. But unfortunately, there was a mechanical fault in the circuit breaker and it didn't open. What do we do in this case? In this case, we move to what's called the breaker filler. Inspiring the revival of a nation.